Normal Distribution, Algebra 211, by Kaiv Davidl and David Lee.
Statisticians don't make it as waiters. Hi, sir. I normally distributed the butter on your toast this morning.
Function of normal distributions. A normal distribution is a function that represents the distribution of many random variables as a symmetrical bell-shaped graph.
Oh yeah. Concepts to know. Mean, which is the average of a set of numbers. Z-score, the measure of standard deviation. And to calculate z-score, all you need is an element of the data set, your mean, and your standard deviation. So you put your x minus mean over standard deviation, which gives you your z-score. Standard deviation is the quantity calculated to indicate the extent of a deviation for a group as a whole.
Question 1. Battery lifetime is normally distributed for large samples. The mean lifetime is 500 days and the standard deviation is 61 days. To the nearest percent, what percent of batteries have lifetimes longer than 561 days?
So the first thing you want to do with this problem is make sure your bell curve matches the problem. Alright, so we're just going to draw our mean here, which is 500. So we're going to put 500 here. And then, okay. Alright, and then keep drawing our standard deviations. We have one here. Okay, so as you probably remember, maybe not, these one standard deviation from the mean holds 34% of the data, like this, and then 2 standard deviations away from the mean is 13.5%. The next 2.35%, and then next is 0.15%, and it's the same for this side, 2.35% and 0.15%. Alright, so 500. So the standard deviation is 61 days. So to get this first side here, we just do 500 plus 61, which equals 561. And as we look at the problem, we can see that the mean is lifetime. The nearest percent would better have lifetimes longer than 561 days. So we just have all of this. So since this is what we want to find here, anything greater than this amount is kind of what we want to find here. So just add 13.5 plus 2.35. 2.35 plus 0.15. This is all in percent. So this will add up to be, right, well, if we add all these numbers together, we get 16%, and that will answer our problem. So, what percent of batteries have lifetimes longer than 561 days? About 16%. There we go. Dang it.
Real-world application problem. Bayside Elementary School is visiting a local amusement park. One of the amusement park's attraction requires the children must be at least 44 inches tall to ride. The height of children at Bayside Elementary are normally distributed with a mean of 43 inches and a standard deviation of 3.4 inches. What is the probability, rounded to the nearest tenth, that a child selected at random does not meet the height requirement for the amusement park attraction?
Nice. Alright, for this problem we're going to be using z-score. Alright, we can see our graph here, mean of 43, standard deviation of 3.4. So let's just put in the first 2 deviations, 46.4 and then 39.6. Alright, well, as we can see that, well, 44 isn't on one of our deviations here, so we're going to have to use z-score. Alright, so using z-score, as we remember, our formula is z equals x minus the mean, alright, over standard deviation. Alright, so first, we're going to set up our equation and plug it in. Alright, well, z equals, alright, we're going to take the required height, which is 44, minus the mean, which is 43 over the standard deviation, which, as you remember, is 3.4. Yay! Alright, so now we have our equation set up. So, this will equal 1 over 3.4, and then you can enter that in your calculator, and you'll get a decimal number. So then, from then, you can go look on your chart here and see which numbers correspond. Well, so now we have 1 over 3.4, which equals, after you enter in your calculator, 0.941. Alright, you can just stop at the fourth decimal place, and then we will look at our handy chart and find 0.2, 0.29. Alright, 0.2, then 9, which is equal to 0.6141. Alright, almost done. Just convert this to a percentage and you'll get 61.41%. Now you can just round this off to the tenths if you want, but it's up to you. Alright, so the answer to the problem is 61.4% of students will not meet the height requirements. Yay.
Assessment question. Professor Hallen has 184 students in his college mathematics lecture class. The score of the midterm exam are normally distributed with a mean of 72.3 and a standard deviation of 8.9. How many students in the class can be expected to receive a score between 82 and 90? Express answer to the nearest student.
Well, this question looks pretty complicated, but I'm sure you can do it through some easy mathematics. Okay, so first let's make a visual approach to this one. Well, first of all, we note that he has 184 students, so make sure keep that in mind because that will become very important in the end. Okay, so let's look at the mean, which is 72.3. We can put that in our graph here, 72.3, standard deviation of 8.9. Alright, so looks like we're going to have to find the percentage between two numbers, which is 90 and 82. So for finding these kind of problems, we just use z-score. So remember our z-score formula, z equals x minus mean over standard deviation. Okay, so we're going to set it up as a subtraction problem like this. Alright. Okay. Alright, so we're going to first use 82. 82 minus the mean of 72.3 over standard deviation of 8.9. Alright, so we're going to subtract that from another z-score formula of 90 minus 72.3 over 8.9. Okay. Alright, we're going to just do that. Alright, so when you put that into your calculator, you can get 1.988764 minus 1.089 in some numbers. Alright, so you want to find the z-score on your chart of each one of these first before you subtract them. That would be a smart idea. Alright. So after we look at our chart, we can find that 1.98 on this is approximately 0.9761%, and then then you subtract subtract the percentage of this z-score, which is 0.8599, and you can plug that in your calculator, and you will get 0.1162. Alright, well, this is a nice number, except it doesn't really give us the amount of students that will receive the score between 82 and 90. So what do we do next? Well, remember this number up here for 894? We just have to multiply it by the total to find the percentage of the students. So 184 times 0.1162 equals, put that in your calculator, you will get 21.3808. Okay, anyway, so it says round to the nearest student. Make sure you remember that. And when you round this to the nearest whole number, you get 21. So in total, 21 students will be expected to get a score between 82 and 90. Alright, great work, everyone. Commonly, mistake when you're doing these kind of problems is when you get down to here, these two numbers here, when you calculate the z-score, don't subtract 1.089 from 1.988764. You'll get a very, strange answer, unfortunately. Well, a lot of people have trouble and remember what a bell curve and a standard distribution is. So I have a foolproof method how to remember. All you need is a ping pong and a ping pong racket. Alright, what you want to do is just hit it like that. And you see, as the slope goes down, it kind of makes the shape of a bell curve, which is like... Alright, so if you want to remember, just remember ping pong ball going up and then down. Have fun. Thanks for watching.